In September of 1859, telegraph operators across Europe and North America watched their wires begin to spark. Sparks from paper messages. Some stations caught fire. Others kept running even after operators disconnected their power supplies. The wires were carrying current that wasn't coming from any battery on Earth. That same night, aurorae appeared in the sky as far south as Cuba. People in Colorado reported being able to read newspapers by the light at midnight. It was the most powerful solar storm in recorded history. We now call it the Carrington event. And in the 165 years since, humanity's only real defense against the sun has been to forecast its outbursts a little earlier and hope our infrastructure is durable enough to survive. A small group of scientists in 2025 proposed something nobody had ever seriously considered before. A way to fight back. An airbag for Earth, stationed in orbit, designed to deploy the moment a storm comes. This is the plan they call Storm Wall. The sun is not dangerous because it is hot. It is dangerous because it constantly streams charged particles outward in every direction, the solar wind. And every once in a while, it sends out a much larger eruption, a coronal mass ejection, a massive cloud of plasma blasted into space, sometimes carrying billions of tons of material. Most of the time, Earth's magnetic field deflects whatever reaches us. But during the most extreme solar storms, Earth's magnetic field can briefly reconnect with the sun's magnetic field. The shield, for a few hours, becomes far less effective at deflecting what's coming through. When that happens, charged particles flood into Earth's near-space environment. Some of them fry satellite electronics. Some pose a serious risk to astronauts. And some heat the upper atmosphere enough to drag satellites out of orbit faster than expected. Meanwhile, on the ground, the disturbance to Earth's magnetic field generates electrical currents that surge through any long conductor. Power lines, pipelines, train tracks. That is how the sun reaches across 150 million kilometers and trips your circuit breakers. In March of 1989, a smaller geomagnetic storm slammed into Earth. In about 90 seconds, the entire Hydro-Quebec power grid collapsed. 6 million people lost power, most of them for about 9 hours. A repeat of the 1859 Carrington event today, by recent estimates, could cause more than $3 trillion in damage to global power infrastructure. It would knock satellites out of service. It would disrupt GPS, communications, banking, aviation. Scientists who study space weather are increasingly certain it is not a question of if a storm of that magnitude hits modern civilization. It is a question of when. Until now, every defense humanity has built against solar storms has been passive. We have spent decades improving space weather forecasting. We have hardened power grids. We have built emergency safe modes into satellites. These help, but they're all responses. Reactions. None of them touch the storm itself. We watch the wave coming. We brace for impact. The proposal is called Storm Wall. It was published in the journal Space Weather by Brian Walsh, a space physicist at Boston University, and his collaborators, including researchers from the University of Michigan and the U.S. Naval Research Laboratory. The concept is, in some ways, beautifully simple. A fleet of large satellites, each roughly the size of a small bus, would be parked in geosynchronous orbit, about 36,000 kilometers above Earth. Far beyond the International Space Station, but still well within the boundary of Earth's magnetic field. Each satellite would carry giant pressurized canisters of gas, lithium, barium, sodium, or even just salt water. When sensors detect that a major solar storm is about to arrive, the satellites release their gases. Sunlight rapidly ionizes the material into a glowing plasma cloud. That cloud, drifts toward the sun-facing side of Earth's magnetic field, and it reinforces Earth's natural defenses. To understand why this works at all, you have to know that Earth already has a partial natural shield called the plasmasphere, a donut-shaped reservoir of cool, ionized gases circling the planet just above the atmosphere. When a solar storm strikes, a plume of this plasma is naturally pulled toward the sun. That extra mass acts like ballast. It slows the rate at which Earth's magnetic field can connect with the sun's. It dampens the storm. Storm wall would simply amplify this, adding artificial plasma to the natural plume. Early computer simulations, run under specific assumed conditions, suggest that several hundred tons of released material could meaningfully reduce the intensity of a severe geomagnetic storm. The precise real-world effectiveness, however, has not yet been tested. In the words of one of the researchers, it's as if you could install an airbag in the magnetosphere. To build Stormwall, the initial proposal estimates roughly 6 heavy-lift rocket launches, using vehicles like SpaceX's Starship or China's Long March 9, both still under active development. On paper, the engineering looks feasible, though the entire system remains a conceptual proposal that has never been built or tested. The politics may be harder than the physics. Who owns Stormwall? Who decides when to deploy it? Could a single nation veto its use? Could it be weaponized? When a venture capitalist suggested running the system as a subscription service that countries could pay into, Walsh's response was simple and quietly emphatic. Either everyone gets it or nobody gets it. For thousands of years, humanity has been at the mercy of the cosmos. We watched asteroids pass. We watched solar storms hit. We rebuilt afterward. Stormwall, if it ever flies, represents a different kind of moment. Humanity, for the first time, deliberately reaching into the space between us and our star and pushing back. It may never be built. The cost may be too high, the politics too hard. The risks of changing near-Earth space, even temporarily, still need to be carefully understood. But the question itself, whether we should, is one that until very recently, nobody was even asking. The sun keeps rising. The storms keep coming. And for the first time in human history, we are starting to think about how to fight back.